Now, if the 2 points had been closer to the vertex, as they will in the next example, we would have needed additional points on the line, and I'll show you how to get those in the next example problem. Let's flip over to the next page. In this page we have the parabola not in its standard form, so we cannot instantly recognize the vertex HK. We'll have to do a little bit of work here. It won't be very hard work though. You'll see it's quite easy. Let's go ahead and begin. The first thing we'd like to do is identify the vertex, and we know from the general form that the x of the vertex is given by negative b over 2a. Now b is the number that multiplies the x term. So this is going to be, since negative 2 is multiplying the x, this is going to be negative 2 over, and then a is multiplying the x squared term. So 2 is multiplying the x squared term, so this is going to be 2 times 2. So this is going to be 2 over 4, or 1/2. So now we know that the vertex is located 1/2 unit to the right. It's somewhere along this symmetry line, 1/2 unit to the right. Now what we don't know is where along that symmetry line the vertex is located, so what we need is now the y of the vertex. And the y of the vertex is f of x of the vertex, and to find f of anything, you write f with empty holes. 2 empty hole squared minus 2 empty hole minus 3. That's writing it with empty holes, and now you put the 1/2 into the empty holes to find the y of the vertex. Okay, 1/2 squared is 1/4, so this is 2 times 1/4 minus 2 times 1/2 is 1 minus 3. So this is 1/2 minus 4, which is negative 3.5. So if we come down 3.5 units, that's way down here, we find the y of the vertex. Well, we found the vertex now. The vertex, which is x vertex, y vertex, is 1/2, negative 3.5. But that's not enough to draw the parabola. Now as you look at a is greater than 0, so this is going to be an upward opening parabola. If we were looking for the minimum, we would now know that the minimum occurred at x equals 1/2, and that the minimum was negative 3/2. We would say the minimum is y vertex equals negative 3.5 at x vertex equals 1/2. So this gets as low as negative 3.5 when x is 1/2. Now I want to finish the graph of this thing. So I need another point, so I'm going to try to find the y-intercept again. And we're going to do that, we're going to set x equals 0, just as we did before, but this is going to be a lot easier than it was before. When I set x equal to 0 here, I get that the y-intercept is 2 times 0 squared minus 2 times 0 minus 3. Well, the fact that I plug zeros into the first two terms make them both 0, so all we have to do is go to the constant, which is negative 3. But wow, that is awfully close to my vertex. Now I know there's another point over here the same distance away, but these points are so close to the vertex I cannot get a good graph from here. I can get a good graph down in this region, but when I get up into here, into the higher regions, I can't tell what it is. So I really need another point on this line, and or on this parabola, I should say. And each time I get one point, the symmetry gives me another point. So if I could just find one more point on this parabola, I would actually have 5 points on the parabola. So it turns out it's really easy. All we're really doing here is a standard table of values, like we always do, x, y. And we found that x vertex was 1/2, and when we solve for y down here to get y vertex down in this region here, we got that y vertex was negative 3.5. And then to get our y-intercept, we set x to 0, and we found that y was 3. So we just need to generate another point, and I can pick anything for my x to get another point. So I'm going to pick x equals 2 and see what happens. If I pick x equals 2, then my y is going to be 2 times 2 squared minus 2 times 2 minus 3. Well, 2 squared is 4, so 2 times 4 is 8, minus 4 minus 3, which is 1. So that tells me when x is 2, that's right here, y is 1, that's right here. And by symmetry then, if I go out 2 units on this other side, there's 1 unit, 2 units. I also have to have y equals 1. Let me do that again. 1 unit, 2 units. I have to have y is equal to 1 right here. So now I get a very good look at my parabola. It comes down, that's not a very good drawing, comes down like that, makes a turn, takes off like that. And there's a good sketch of my parabola. My minimum equal negative 3.5 at x equals 1/2. Okay, there's your complete graph of the function with its minimum. Well, I missed 2 up here, didn't I? Oh, no, I hit it all right. Yeah. Let's see if I got that in there right. See, moving 2 was 1.5 units this way. I think I moved a little more than 1.5 units this way. Yeah, I actually moved 2 units this way. This point should have been here. Moved over a little bit too far. Let me erase that part. I was wondering why that didn't look symmetric, and that's because I moved a little too far to that other side. So there's a little bit better drawing of your parabola. Still a little lopsided. Do your artwork better than I do, and good luck to you. That ends this podcast.